Okay, so looking at this here, first of all, just realising that if you have 1 plus x to the power of 8, that is 8c naught, 1 to the 8, x to the naught, plus 8c1, 1 to the 7, x to the 1, all the way up to 8c, 8, 1 to the naught, x to the 8. So it ends up being 8c naught plus 8c1 x plus all the way up to 8c8 x to the 8. Now looking at this, what we're interested in is the coefficient of x to the 3. And we're going to equate coefficients of x to the 3 from this side and from the other side. So the coefficient of x to the 3 on the left-hand side would be 8c3, and that's where the 8c3 comes from. So now if we look at the coefficient of x to the 3 on the left-hand side, so if we expanded the left-hand side, we have 3c naught plus 3c1x plus 3c2x squared plus 3c3 x3, and that's going to go with 5c naught, 5c naught plus 5c1x plus all the way up to 5c5 x5. So you look interested in here in which one, when you open the bracket up, will give you an x to the 3. So 3c naught would have to go with 3c naught would have to multiply with 5c3 x to the 3, because that would give you an x to the 3. And 3c1x would have to go with a 3c2 x to the 5c2, in this one. So this would, you have to go with a 5c2 x to the 2. And the 3c2 x squared would have to multiply with, so this one would have to multiply with 5c1 x to the 1, because squared and a 1 makes a 3. And then 3c3 x to the 3 would have to go with 5c naught x to the naught. So if you listed all these coefficients on the right hand side that went together to make a coefficient of x to the 3, you'd have 3c naught 5c3, notice that. Then you'd have 3c1, and you're adding all these coefficients together, 5c2, that's that one there, plus 3c2 5c1 plus 3c3 5c0. They are the coefficients of x to the 3. So if you look at this, the answer is almost in the question. So what you have to do is just say equate coefficients of x to the 3, and this would equal 8c3, and then that would be proven. Okay, so looking at this, very similar. If you look at the left-hand side, the coefficient we're looking for is the coefficient of x to the 4. So on the left-hand side, that's just going to be 10c4. On the right-hand side, we're going to group together. So we're going to have 5c naught plus 5c1x plus 5c2x squared all the way up to 5c5 x5, and we times that by 5c naught plus 5c1x plus 5c2x squared plus 5c5 x5. So the ones that couple the 5c naught, that would go with the 5c, we want to go next to the 4. So you'd have to go with the 5c4 x to the 4, and I've just noticed too, I had to change all these need to all be 5s in my question. So they need to be 5s. Okay, so that would give me 5c naught, 5c4, x to the 4. So to give me x to the 4. 5c1x times 5c3 to make 4, x cubed from the other one. So you go 5c1, and you've got to do it with a 5c3. That would give you 5c1, 5c3, and that will give you an x to the 4. Then 5c2 would go with a 5c, we're trying to get 4, 2. So that would give you 5c2, 5c2, and that would give you an x to the 4. So the other ones are, we've got 5c3. 5c3 will go with 5c1, and then it'll be 5c4, and that would go with 5c0. So if you added up all the coefficients of x to the 4 here, on the right hand side, you would have 5c0, 5c4, plus 5c1, 5c3, plus 5c2, 5c2, plus 5c3, 5c1, plus 5c4, 5c0. Now, NCR equals NCN minus R, so that means that 5c0 will equal 5c4, 5c1 will equal 5c3, and etc. 5c, yeah, that's probably it. So that means that these all become squares. So it becomes 5c0 squared plus 5c1 squared plus 5c2 squared plus 5c3 squared plus 5c4 squared. And that is going to equal the coefficient of x to the 5. So that's going to equal the coefficient of x to the 4 on the left-hand side, which is 10c4, and then that's proven. So the one that was actually in the 2020 HSC, which was from the old binomial course, so it's a bit out of syllabus, but people have asked me. We'll just run through it. So we've got, if you look at the left-hand side, and you look at that, we're looking for the coefficient of x to the n. So the coefficient of x to the n on the left-hand side is 2nc0. If we look at the right-hand side, and we look at the coefficients, see this is going to be, I'm just going to write the expansion, nc0, x1, nc2, x2, ncn, xn, and we're going to times that by nc0 plus nc1 x plus ncn xn. So therefore we have nc0 that will match with ncn xn from here to here to give you an x to the n. nc1 would have to go with ncn minus 1 because that'll be x to the 1 and n minus 1, and in total that'll give you an x to the n. nc2 would go with ncn minus 2. And then you go all the way down till you get to ncn and then nc0. And then you go, but ncr equals ncn minus r. So nc0 equals ncn, nc1 equals ncn minus 1, etc., etc. So therefore that allows you to create the squares. And it means then you can write the right-hand side with what's there. So you can just say that would be, once again, I can just see in this question, I've made that a 2. They should be n's. Should be n's. And copy it right. So on the left-hand side then, the nc0 times ncn becomes nc0 times nc0, which is nc0 squared. And nc1 times ncn minus 1 will become nc1, which is nc1 squared. And this allows you to get all of the squares. ncn times nc0 will be ncn, which is ncn squared. So therefore on the left-hand side, on the right-hand side, we get nc0 squared plus nc1 squared plus ncn squared. So if you equate the coefficients of x to the n on both sides, you get 2 ncn will equal all of the above up there.